NCERT Physics Class 11, 7th chapter, which is System of Particle and Rotational Motion, question number 7.23. So in this situation, a man stands on rotating platform with his arm stretched horizontally, holding a 5 kg stone in each hand. 5 kg weight in each hand. The angular speed of initial is 30 revolution per second per minute. The man then brings his arm to close his body with the distance of each weight from the axis ranging from 90 centimeter to 20 centimeter. The moment of inertia of the platform and man can be taken as 7.6 kg meter square. What is new angular speed and what is kinetic energy? Is the kinetic energy conserved in the process? So moving to first part, which is A. In this situation, we can see that initially the platform is rotating and the arms of the person are stretched. So while moving the hands or while moving the arms closer to him, there is no external torque on the system. So as there is no external torque on the system, we can say that initial angular momentum is equal to final angular momentum. So this is problem of conservation of angular momentum, that initial angular momentum is equal to final angular momentum. So in angular momentum, we can write the angular momentum can be written as I into omega, where I is moment of inertia. And in order to find the value of moment of inertia, the situation is that moment of inertia is due to initial moment of inertia. The moment of inertia is due to person, platform, and the stone. So due to person and platform, the moment of inertia is 7.6. Now, in order to find the moment of inertia due to stone, that is equal to mr square. So two stone are there. So the moment of inertia due to stones is 2m into r square. Initially, the value of r is 90 centimeter. That can be written as 0.9 meter. So on solving this, the value of I1 comes out to be, initial moment of inertia comes out to be 2. Mass of each stone is 5 kg and the value of radius is equal to 0.9 meter. So initial moment of inertia comes out to be 15.7 kg meter square. Initial moment of inertia, this is equal to 15.7 kg meter square. Now, final moment of inertia. Final moment of inertia is due to moment of inertia due to man and platform, which is equal to 7.6, and due to stone, that is equal to 2m into radius, and the radius is equal to, initial radius is equal to the final radius is equal to 20 centimeter, which can be written as 0.2 meter. So the final moment of inertia can be written as 7.6 plus 0.4, that can be written as 8. By substituting the value of m as 5 kg, the final moment of inertia comes out to be 8 kg meter square. Now we can use the concept of conservation of angular momentum, that I1 omega 1 is equal to I2 omega 2. So we can say that I1 omega 1 is equal to I2 omega 2. Initial moment of inertia, that is equal to 15.7. Initial omega is 30 revolution per minute, is equal to final moment of inertia is 8 into omega 2. So the value of omega 2 comes out to be 58.88 revolution per minute. This is the value of final angular velocity. And then this we can say the final angular velocity is increased. So the final kinetic energy would be increased, as final kinetic energy can be written as half I final into omega final square. So omega final into omega final. This expression will remain same, as I initial omega initial is equal to I final omega final and a factor of half. So this expression would be remain same. So we can say the final kinetic energy is equal to omega final time initial kinetic energy. So in this situation, the final kinetic energy is increased by factor of omega final, and this increase is due to the work done by internal forces of the man, as there is no external force acting on the system. So this increase in kinetic energy due to internal forces inside the man.